So good morning to everyone, or good afternoon, depending on where you are, to everyone who's joining us. We're just going to start in 1 minute, so just please let me know if you can't actually hear me. I'll just double check the microphone volume. Right, so we'll start now. Yeah, so we'll start now. Please let me know if you can't. If you can't hear me. We'll run through the agenda. It should be a quick presentation. It's just fairly, there's not much to it. Just a basic demonstration of how we can cover XSL from running within a WebC message broker execution group. So basically, just a couple of quick minutes to discuss what we're trying to do, what we're trying to do with Sonar, what we're trying to do with code coverage and test-driven development. Just 1 minute to show exactly what the setup and configuration looks like. It's fairly simple. And then just a couple minutes for the demonstration. Then any questions we'll have at the end. Otherwise, we'll jump off them. So what are we trying to do? Why are we doing test-driven development? Why are we trying to capture test coverage to work out what we are testing? So what we're trying to do with test-driven development is help our business users and our developers understand the behavior of the system. So by writing things in the concept of tests, we can work out, we can help describe what the system's doing and how it should work under different scenarios, different preconditions, and B, we can then demonstrate that it does actually execute those scenarios in that particular way, which gives us confidence in that our system's performing the way we've described it to our users. There's various tools for doing test-driven development or behavior-driven development, such as Cucumber. If you're using web-driven applications, you might use Cucumber in the combination of something like Selenium to drive the GUI. Or you might use something like Fitness if you're doing a lot of, I suppose, maybe potentially calculation-based scenarios or calculation-based descriptions of behaviors. And then you could incorporate that with various technologies, such as executing Java tests, such as through things like JUnit or Fitness, or you might want to write your behaviors get executed by a driver such as MQ or a web session using something like JSON. So for the purposes of this demonstration, what we're doing is we're going to be triggering our execution group, which has got some style sheets in there. And our style sheets are covering our business logic. In this case, it's a manipulation of data on the way through to produce data on the way out. And this would be driven using a fairly simple means, a web connection. So a HTTP request will go to the execution group that will trigger our style sheet to be run, and the results will be will come out at the other side, which we could then test to verify. And the thing we're interested in today is then we're going to show how we're marking which parts of the style sheet are actually being processed to give us an idea of what other tests we need to do to confirm that the code is performing as we expected, or that we've written enough code and we might be able to remove some code or delete some code because it's not required as part of our implementing our logic. So Sonar itself is the platform that the plugin works in, and it has it allows you to collect various metrics about your code, one of them being test coverage. So there's two or three methods in Sonar to collect test coverage. If you're working with Java or the Java-based languages, there's plugins for things like Corpatura, things like Emma, that import your coverage files that you'll build and mark them against your code. In the .NET world, there are plugins that import your NUnit tests as part of the .NET .NET infrastructure or .NET plugins for SonarQube. And the third one, we're making heavy use of something called the generic code plugin, a generic code coverage plugin, which I can show you here, which is pretty easy to configure in Sonar. It's just a matter of adding a plugin, which is this Sonar generic code coverage to your extensions and restarting your Sonar instance. And then if you give Sonar, you indicate to Sonar where your which you'll just do here, and this is the sample project we're using. If you indicate to Sonar where your coverage file is going to be located as part of your project, it will upload your coverage file and upload your code as part of its processing and mark the two together. So what it would look like in Sonar, and we'll just quickly show you what we're trying to achieve, and then we'll give it a run. So what we will look like in Sonar is we've got our dashboard. This is SonarQube 5.4. We have our dashboard, and inside our dashboard we have a summary of coverage. Now inside our summary of coverage, we've got coverage across message flows and ESQL, but in this case we're looking at a development process predominantly based around, or a mediation process predominantly around style sheets. So we're just going to look at the two style sheets we've got as part of our source code here. So what we've got here is two style sheets, one with coverage and one without. So what we have here is just a hack together style sheet. It doesn't do a lot, it just demonstrates all the different paths of different ways that we can logically pass through our style sheet. So we've got basically a match, we've got some if conditions, we've got a choice, we've got a when else, sorry, when otherwise, we've got a for each iteration, and lastly we've got a template calling another template, in which case we've got a second template with an additional if statement. So you can see here the red lines indicate logical paths through the style sheet that we can take. So we're marking paths through the code rather than individual lines of code, because that gives the least amount of false positives or noise. So in code where you have we have a 50-line procedure, and if you say you've got 25 lines covered, you would say you've got 50% coverage. But if that same code has 4 branches and only one of those branches it's covered, logically you've only got 25% coverage. So you're more interested in the parts of the code, or the different paths through the code which you can execute, rather than the individual code. So in the case of our style sheet here, we know when we've got in this case here, within this in the case here, if we know that this particular block of code is executed, then we know it's all executed. There's no additional path through this code where it could divert. So I'll just stop for a second. Does anyone have any questions? So I'll continue on. So that's our essentially that's our untested style sheet. So that style sheet here, we see a lot of red. So in this case here, we've got 11 points of coverage, and they're all marked as red to say indicate not covered. Our second style sheet is one that we actually will be executing, the one we will be deploying, and from there we can see that we've got a green line of coverage here to indicate that the actual top level match of this style sheet is actually being executed. So we've got, if this was our only path through our style sheet, we would have 100% coverage at this point on line 38 here. Now we've got multiple paths through this style sheet, so very similar to the other style sheet. We've got if conditions, when conditions. So in this case here, we've got 3 if conditions where we haven't executed the lines within them. So we haven't, they're marked as untested or uncovered. We've got a when condition, or a when case, and we can see here that the condition is actually being executed. And so we are entering the code, we are entering the when condition, and we also have an if condition, and we see here that we're actually entering this if condition as well and executing this branch of the code. Now our test is fairly rudimentary. All we're doing is sending through a HTTP request, which is going through the style sheet once. So we've got basically one permutation, one path being executed. So we're not going to cover all our paths, but in this case here, we can see this is the path that's not covered. We're not covering the otherwise. Within the otherwise, we're not covering that if test there. So we can see here we've got 2 different paths here, when the when condition is executed, when the otherwise condition is executed, and within those you've got another path. So we've got a second path. So we've got 4 permutations we'd need to test to get 100% coverage there. So we can see here we've covered one of those permutations. And again, we've also got this for each loop, and so we can see here that we haven't entered the for each loop. We haven't executed this line of code. So that's the end result. We can see what parts of our code or parts of our style sheet have been executed and what parts of our style sheet haven't. And from an overall perspective, we can then look at look at our overall test coverage. We can see the amount of lines of code coverage, and on our dashboard, on our dashboard, we can see, let me just navigate back to my on our dashboard, we can see our overall test coverage sitting at 2.4%, which as a development team, we've probably been not all that happy with, but this is a demonstration project. So here, and so here we've got a combination of ESQL and style sheets, and we can see where we might want to look at executing our increasing our test coverage, and where we might want to and where we've got sufficient. So in this case here, our style sheets sit halfway up. So we've got other code which isn't executed at all, and then we've got our style sheet which are partially executed. So that's our end result. We've got a summary of what we've tested. So to get there, there's 2 technical steps that need to be done. Which are highlighted here in our sample build process. And now, because of the nature of the way the style sheets are actually processed, the way we instrument the tasks, there's a couple of manual tasks you need to do. One is you need to provide the logging framework or the instrumentation recording that we use, the jar file. We need to provide that to the shared path of the execution group in our test environment, so that we can log our style sheet events or our style sheet lines being executed. The second one is we need to change one of the parameters to allow the particular jar file that we've added to our shared classes to execute. So these are test-only changes. So we originally had planned to incorporate the instrumentation as a completely standalone process, but just with trying to get it running in the execution group, we've found that we've had to add some additional one additional jar to the shared path to make it work. Otherwise, here is a sample build script, and we can use any number of tools to run this process. But essentially, what we've got here is something called instrument task, and its job is to take a bar file that we've built. So we're building a bar file. Then our instrument task takes our bar file that we've just constructed, our source code that we're looking to compare the coverage for, and produce something called a coverage report, which is what we're going to feed into Sonar. And then we feed that Sonar into that coverage report into Sonar here. So we take the instrumented bar file, or build a bar file, take the instrumented bar file, place it within the broker or execute it within the broker. Then we run our tests. And while we actually in parallel running our tests, we start something called the test listener. Start something called the test listener, which also refers to the same coverage file, and its job is to mark off within the coverage file, which I can show you here. And its job is to mark off the steps, which I'll show you here in a second. Sorry, apologies. Is to mark off the individual lines being covered. So in this case, we're interested in the different branches marked within our style sheet. So the instrumentation creates this coverage file. The listener loads this coverage file, and as the test gets executed as part of our testing harness, which essentially is just sending a URL request to a HTTP input node, we mark off all these tests that actually been, all these lines of code that actually been executed. And we can see here that we've got covered and uncovered lines. Covered means obviously covered, uncovered, a remaining branch that hasn't been covered. From then we run our Sonar analysis, and its job is to run the plugin, or I should say its job is to analyze the code and make sure the code's actually up to date in Sonar, and then run pass in the path to the coverage file, which will then be imported into Sonar to give us our coverage report, coverage reporting. So that's the style sheet coverage in a nutshell. So as I've shown, it's two fairly simple classes, but obviously the more style sheets you have, the more different paths through the code you want to be looking at, and the large amount of coverage information you actually be able to gather. But it's fairly, as I said, it's fairly a simple process, but hopefully quite useful and powerful for teams that are doing test-driven development and teams that also have a lot of style sheet logic. So in conjunction with ESQL and message flows that we can cover, now we can cover style sheets. So thank you for joining me, and if you do have any questions, please feel free to email me at richard@bettercodingtools.com. Otherwise, reach out to us via our contact page. So if there's no questions, I will jump off and let everyone get on with their day. Thank you.